response. In this fight or flight situation, two hormones called epinephrine and norepinephrine will be secreted in high amounts into the blood. These hormones are produced in the adrenal glands, which are positioned on top of each kidney. The adrenal gland is composed of an outer layer called the cortex and an inner layer called the medulla. Epinephrine and norepinephrine produced are from the amino acid tyrosine in the medulla of the adrenal glands. Additionally, norepinephrine can also be produced directly from sympathetic nerve endings throughout your body. Together, epinephrine and norepinephrine are called the catecholamines. They immediately provide glucose from breaking down stored glycogen and fat to your muscles so that you can either fight or run away. These same responses will occur when you begin to ramp up the intensity of exercise. With intense exercise, catecholamines will be released, and you will likely notice that your heart rate and respiratory rate will increase to improve blood flow and deliver oxygen to the organs and tissues. Again, so you can have a better fight or flight response. And catecholamines will also begin to mobilize or break down stored body fat when they interact with specific receptors called adrenergic receptors or adrenoceptors. Adrenergic receptors are receptors that respond specifically to catecholamines. And because exercise and catecholamines both lead to lipolysis or fat breakdown, it is easy to see why exercise can be effective at burning fat as a fuel. If you simply exercise regularly, you take advantage of the catecholamine response that occurs and will lead to the breakdown of fat. But nutrition must also be considered here, along with the type and intensity of exercise being done. For example, a long, slow training session would likely have the lowest catecholamine response. But if you work out intensely with enough fuel to go all out, but not too much that you stop lipolysis, you may have a great recipe for fat burning, in part because you have elevated your catecholamines the most with this type of workout. This is a trial and error process, though. You have to experiment with your food and your workouts. Then you simply adjust accordingly. Remember, too, that if you exercise at an intense level, you may also be setting yourself up to best burn calories even after an exercise bout is finished. This afterburn effect can last from just a few minutes to 24 hours, depending on your exercise intensity. Just like other hormones we've reviewed so far, the thyroid hormones also have a powerful influence on metabolism, body composition, and health. And they may be the most misunderstood hormones when it comes to body composition. How many of you have blamed your weight gain on a faulty thyroid hormone? I have heard this dozens of times, but the truth is that while the thyroid problems can certainly contribute to weight gain or even weight loss, the situations where this is the primary reason for weight change are pretty rare, particularly when considering the excellent advances in medications for diagnosed thyroid problems. The thyroid hormones, as expected, are produced by the thyroid gland, located in the front base of your neck. The two hormones released from the thyroid gland are thyroxine, or T4, and triiodothyronine, which is T3. T4 is produced in greater amounts, but T3 is the more biologically active thyroid hormone within the body. In other words, T3 actually gets the job done. These unique messengers affect most bodily functions and influence nearly every tissue in your body throughout your entire life. Frankly, it'd be easier to discuss what they don't do. In short, the thyroid hormones regulate body temperature and are required for efficient metabolism, normal growth and development, and for the actions of many other hormones. Without normal levels of thyroid hormones and growth hormone, for example, infants and children experience growth and developmental problems. Because the thyroid hormones are involved in many metabolic processes, they also play a role in maintaining and increasing your resting metabolic rate and production of body heat in a process called thermogenesis. Heat production is another process that uses energy and can influence your body composition over time. Many of the bodily functions that thyroid hormones influence expend energy, and we need to replenish that energy by eating. Normally, T3 will increase energy expenditure after we eat, or burn more calories as our food is being broken down and transported to various cells within the body. This can help to regulate weight when thyroid hormones are within a normal range. Now, it's clear that we need to have normal T3 levels to be healthy in a number of ways. Take, for example, a study in which obese individuals reportedly had higher concentrations of T3, increased energy expenditure, and metabolic rate. This correlation may sound odd to you. We just said that T3 increases calories burned. You'd expect people who are obese to have lower concentrations of T3. But this increase in T3 in these obese subjects may be an adaptive response to prevent further weight gain. And T3 may be increased in an attempt to reduce the amount of energy being stored as fat. On the other hand, T3 has been shown to be very low in underweight subjects and during starvation. And this is likely your body's attempt to slow metabolism and conserve energy. These adaptations look like they are in place to reduce fat mass in the obese and preserve or increase fat in the underweight. It is simply a protective mechanism to maintain healthy body weight. Unfortunately, some people do experience chronically low levels of T3 and T4, which is called hypothyroidism. In this circumstance, weight gain is likely. If the opposite occurs and T3 and T4 are chronically high, this is called hyperthyroidism and would likely result in weight loss. Now, I want to mention that in otherwise healthy individuals who are taking synthetic thyroid hormones, your doctor has likely brought your blood levels of T3 and T4 into normal ranges. So, if you're taking medication for diagnosed hypothyroidism or low thyroid, then you don't have your thyroid problem to blame for weight or fat gain anymore. Your levels are normal because of the thyroid medication that your physician has prescribed. As one endocrinologist that I know stated, the rate of obesity does not match the rate of thyroid disorder diagnoses. Your body is perfectly capable of maintaining a healthy body composition with smart exercise and quality nutrition, so long as your thyroid levels are regulated. Now, understanding how hormones, sex, and age influence your body composition is also fascinating. We have known for some time that men naturally have more lean muscle compared to women, while women tend to have more total body fat. This is often explained by the location of body fat and the unique reproductive function needs of women. The higher level of fat and lower level of muscle in women typically means that women have a metabolic rate that's about 5 to 10% lower than men of the same height and weight, because muscle mass is more metabolically active. In addition, women are 5 to 8 times more likely to develop hypothyroidism compared to men, which, if not treated, may lead to weight gain. In an interesting scientific paper on sex differences in body composition and insulin resistance, The authors of this review stated that men, who tend to have more fat around their internal organs, were more insulin resistant than women, who tend to store their fat around their arms and legs. So the health consequences of excess fat depend not only on the presence of body fat, but where that fat is located. However, as we age, our hormones also change, and this influences our muscle tissue and fat storage. After menopause, for example, women gain more abdominal fat mass due to the decline in estrogen concentrations. It has also been shown that women burn fat less efficiently after menopause, both at rest and during exercise. The prevalence of hypothyroidism, or underactive thyroid, increases with age too, affecting about 9% of men and women over 60 years old. Now, this may have implications for weight gain in later years because, as you know, a decrease in thyroid hormones slows metabolic rate if it's not treated with medication. Additionally, decreased muscle mass and strength occurs as we get older, resulting from a gradual loss, about 5 to 10% per decade, of the skeletal muscle after age 30. But it's not all doom and gloom. These massive changes to body composition only occur if you choose not to exercise or eat properly. In fact, there is other evidence that shows excellent muscle mass, quality, and function in those who are lifelong exercisers and